types of testing: functional testing, then non-functional testing, manual testing, automation testing. Likewise, there are different terms. Take our whole application, and if we break this into different parts, knowledge, or have you heard anything related to the pyramids? Hello, fellow quality engineers. Good morning and welcome to your favorite YouTube channel. Wait, don't leave. So, this is not a tourism page. Yeah, you are at the right place. It's your favorite YouTube channel, the QV Bro. Just the background was little bit changed for today. Yeah, not little bit, a lot of different. Yeah, I'm at the Great Pyramid of Giza, Egypt. So, when I visit the Great Pyramid, it reminded me something related to the quality engineering, our quality engineering practice. So, can you recall maybe from your knowledge, or have you heard anything related to the pyramids? So, your ideas you can share in the comment section. Let's see who gets it correctly. Yeah. So, if you see the shape of the pyramid, so you can see the base, and when it goes to the top, the area will reduce. Right? Kind of the triangle shape. The bottom part, you can see the base is the highest at the bottom. So if we slice this pyramid into, let's say, for 4 pieces, not the Great Pyramid. So if you slice it into, like, virtually, if you slice it to couple of parts, let's say four pieces horizontally, so the base will have the highest area, and the top triangle, that area will be the lowest area, right? So the same principle, like the same approach, we can apply to the quality engineering. There is something called the test pyramid. So in the test pyramid, we talk about how we should approach the testing. So today we are going to talk about different types of testing, and with those types, we can apply the same types of testing to this testing pyramid. So using the test pyramid, you can decide what type of testing you need to have, and like how many percentage or the coverage. So which type should have the highest coverage and which type should have the lowest coverage. Likewise, you can plan using the test pyramid. So in couple of minutes you will get to know more about testing types and the test pyramid. So today we are going to discuss about types of testing. When it comes to testing, so as we discussed in our last video, testing was a step in the SDLC, the software development life cycle. And also I mentioned that we do different types of testing there. Then we get the actual outcome. Then we might have the expected outcome. And then we do the comparisons. And from there, we will extract out if there are any issues or bugs. Also, when we talk about this testing or the phase in the software development life cycle, it is not only one type of testing. There are different types. Already you might know about, or you might have heard about these things. We are talking about functional testing, then non-functional testing, then we talk about manual testing, automation testing. Likewise, there are different terms. All these are different types of testing. But why there are so many terms, or why there are so many different types? All comes under the same category, or those are fall under different categories? At the end of this video, you can get all these questions cleared. All these different types of testing we can categorize based on different characteristics or different properties of them. So I will start with manual and automation testing. These two we can categorize based on the execution method. That means how you do execute these tests, how you perform the test cases. A human or a script. Likewise, we can categorize it based on the execution method. So under that, there are two types called manual testing and automation testing. First, I will talk about the manual testing, the easiest one to explain, not to perform. So manual testing is like there is a human or the tester himself. I will take the example of testing e-commerce website. Okay, so he will go to the browser and go to the e-commerce website, the URL, and then he will follow some test steps which has been created already previously, and the tester is following each step manually. So for example, let's take the first test is about the login scenario. So it says under preconditions, maybe it will say go to this particular URL. Okay, so now he will copy the URL, paste it on the browser and hit the enter. And now he will see the expected outcome. The website loads. Then he will go to next step. It says click on the login button. So now he goes and click on the login button. Then the expected outcome says there should be an error message. Username and password are required or something. So now he checks it on the actual behavior. So he click on the login button. Now he's check whether there is a error message as mentioned in the expected outcome. If it is there, then the particular step is passed or the test case passed. Let's take another example. First test case was about the incorrect login. So login without username password, trying to login, and the outcome was achieved successfully. The user was not able to login and he got the error message. Now he will mark the test case as passed and he will go to the next test case. Test case number 2, it says correct username password and successful login scenario. Okay, now he follow the steps. So it says enter the username in the username field. Next step, enter the password in the password field and click login button. Expected outcome says should successfully redirect to the home page. But unfortunately, due to a bug on the system, the login failed and the user gets the error message unsuccessful login or login failed or something like that. He gets the error message. So now the expected outcome and the actual outcome are different. So in this case, now we have an issue or a bug. So now user will mark the test case as failed and he will report the issue. So this is how manual testing is done. So all the steps, all the executions, the results, the reporting, everything will be done by the tester by himself without any use of any scripts or any automation technology. So all 100% human interaction. So that is manual testing. So I hope now it's clear. Next type, based on the execution method, we have automation testing. And automation testing, I will take the same example. Now in this case, let's say these two scenarios are already automated using some of tool or some of technologies. Let's say Java and Selenium. So now there are two scripts. Either the tester can go and run the automation script and see the output. First one will pass and second one will mark as fail. So if we go more, let's say these scripts are already plugged into some CI/CD pipeline. So now user just need to go and click a button. It will start the pipeline. It will run the test cases and it will generate the report. So now you need to go and check the report. It will have test case 1 pass, test case 2 fail, and also maybe some screenshots or the error message, everything will be there. So that is automation testing. Automation testing can be 100% automated or partially automated. It depends on how you approach that one. In the first scenario, I mean, we have only the script. So the user go and run the script, then he manually verified the results like that. But on the second scenario, we had it plugged with the CI/CD. If we go more another level, when a new deployment done, the CI/CD pipeline will automatically start and it will run the test case and generate the report. Likewise, there can be different levels of automation testing. However, automation testing means we are using automated scripts, different tools and technologies which facilitate running test cases automatically. So there is no or less human interaction when compared with manual testing. So that no or less human interaction will depend on how you approach the automation, as I mentioned on different examples. In the 3 scenarios I mentioned, human interaction will be vary according to the particular scenario. That's how you can do automation testing or how you can achieve automation. So I hope now it's clear. 2 different testing types based on the execution method. So here the categorization was done based on the execution method, the property. Okay, so I hope now it's clear. So now it's time for us to go and check the second method or second categorization. The second categorization is based on the technique. Under this, we have 3 different categories. Whitebox testing, the same will be referred as glass box or clear box as well, and also there could be some other different terms too. And then we have gray box, and the third one is black box. When you check at these terms, white box, gray box, and black box. White box, let's think of an example of a box created fully from glass. So if you put something, okay, I have a ball. I put the ball inside the box. And now from outside, I'm trying to look at the ball. If it is a glass box, a clear glass box, so from outside I can see the ball which is put inside the box. But next one, I will hold the gray box scenario and I will go to the black box now. Let's say the same thing, the same box, but now this time it is created from some hard material like metal. The visibility is none, you can't see through. So now in this scenario, I put the ball inside this metal box. And now I'm trying to look at the ball from outside through the metal. So it's obvious, right? You can't see it. So that's the two different things, the clear box and the black box. If it is a white box scenario, you can see inside. If black box, you can't see through. White box, so the same scenario applies here. You have the code. You have or you check the code in white box scenarios. But black box, you have no idea about the behind the code behind. What you see is the build product, not the code. I hope it's clear now. In whitebox, you check the code, or how the coding is done, how the variables are created, how the methods are created, what are the methods available, so what are the inputs taken into different methods. Likewise, you know all the flows on the code level. But when it comes to black box, you don't know anything about the code. You don't know how many methods are there, how many classes are there, nothing. What you see is the final product. So you see it from the user's perspective. What you see is the user requirements. What you know are the user requirements. And you are testing against these user requirements. But in the white box scenario, you are testing against the code. So that's the difference between white box and the black box scenario. The unit tests created by the developers. So they check the code and they write the unit test cases for the code they know. Let's take the example of a unit test. I will definitely walk you through on how to create these test cases, unit test cases and everything in later videos. Don't worry. For the time being, for this particular video, I will just give you the definitions and to give you the idea. So let's take an example for this scenario. We have a method called sum. It takes two inputs, input A and input B. Both integer values, and the output will be another integer. If we pass 3 and 5 to this method, it will output 8. So I hope it's clear. So when a developer writes the unit test case, now he knows about this method. So he knows it takes two integers and it will return an integer. When he writes the unit test case, the assertion he writes is like he will pass 3 and 5 and he will check the assertion. His expected outcome is 8. Then he calls the method and pass 3 and 5 and he takes the output and he compares with the expected. If the actual return value is also 8, then that means the test case unit test is passed. If the value is wrong, that means unit test failed. That means the method is not behaving correctly. There is a bug in the method. So that's how unit test cases are written. The person who writes the unit test case have full access or have full idea about the code flow, and for that code flow, lines, methods, everything, and then the branches like the if else, the loops like the for, while, do, all those things he will test at code level. And also there are different coverages, like we have line coverage, branch coverage, method coverage, class coverage. Likewise, based on the number of unit test cases he writes, and from those unit test cases, like how many lines will be executed, how many branches will be executed. For example, let's say we have a if else scenario. In that case, at least we need to write two test cases. Why? First one, if we pass some value, it will go through the if flow, if branch. That is one branch. Then we need to pass some other value which should go through the else as well to cover that branch. So in this scenario, at least we need two test cases, two unit test cases to cover the two branches. So that is branch coverage. Line coverage means how many lines you covered on the code. Likewise, the class coverage, how many classes were covered. Likewise, there are different coverages. You can get these stats based on your unit test cases. Now, almost like all these IDEs now support these coverage statements, and also there are the third-party tools where you can get more information, more stats about these coverages. So likewise, you can improve your unit test cases or increase your unit test cases to increase the coverage. So this is white box, glass box, or clear box testing. I hope now it's clear. Then black box, as I mentioned, this is the normal testing what quality engineers does. So we have the functional requirements, maybe in SRS documents or as stories. Following those, we have created our test cases for the user behavior or the user scenarios for the features. Then following those steps on the test cases, we do the testing. Could be manual or automation, as we previously discussed. It was based on the execution method, now the technique. So those are black box testing. So the quality engineers doesn't have, or we don't need to pay attention to the code behind, because we don't check the code and we don't ask how many classes are there, how many methods are there. In our testing, what we need to cover is the different features, all the features or the user behaviors, all those scenarios. So this is black box testing, where testing was performed without paying attention to the code, the actual code. Then we have gray box. So I hope now you can think what is gray box. So it is kind of a hybrid scenario where we use both techniques of white box and the black box testing. So these are the three different types of testing where we can categorize under based on the technique on how it performed. I hope now all are clear. Now let's go to the next type. Now this is the third type based on the levels. In last slide, I talked about unit testing. There I mentioned unit testing is done by developers paying attention to the code. And I took an example and explain how these different line coverage, branch coverage, and those things are covered. So I hope it's clear for you what unit testing. And there you can get the idea units. We test very small units, a method. So if you take our whole application and if we break this into different parts, the whole system we have, then from the whole system we can maybe break into some few components. Those components also we can break into few more other components, and these components we can break into smaller units. Let's take the bricks where we have used to play in our childhood, or the Legos, like these things. So we have very small unit. Using multiple units, you can create some small component. Then using few different components, you can create one large component. Using this, you can create useful or some meaningful figure or something. Let's take the example of building a home. We have these bricks. Using bricks, we make the walls. Then we put the roof, we put the doors, we put the tiles and everything, and then we called it a home. The home is the full system. It contains multiple components like the roof, walls, floor, other components. Then each component is made out of different small units. For example, wall is made out of very large number of bricks. So those are the units there. Likewise. So now I hope it's clear. So the same comes in the coding as well. If you take the whole system, the e-commerce application, it is built using multiple components like the dashboard, the email components, then the cart, likewise. Then if we take one component like the dashboard, now it is built using different units. Under that we have multiple methods. So these are smaller units. The smaller units start from the methods lines like. So here under unit testing we cover those things. Then we go to the component testing. Multiple units we test together, not a single unit. The same example I took previously, the creating the sum. So that is one unit. Then maybe we have multiplication, another method, multiply, another method, division, likewise. So likewise there are multiple units. So those units we test separately, individually, passing values to each unit. Then one component. Let's say we have, this is a calculator application. Those units together, call it as a component. Now multiplying units, we have created the component, and now we test the component as a whole. But again, multiple components need to be integrated together to build the system. Because, for example, let's say there is one component A and B. Component A will take some input from user, and it will do some calculation and it will generate an output. This output will be passed to component B as the input for that. Then it will do more calculations or some reporting, and then it will give the actual output to the user. Okay, the same scenario, the calculator. Okay, now the units, we have different methods. So addition, subtraction, division, those together we called it, let's call it as the, let's say, math component. And there is another component called the print component, where it will print the output to you, output and give it to the user. So first, user will give input to the application through the UI. Then he will click the button or subtract, or then he will submit. Then it will come, the inputs will come into our first unit, the math unit. Then under that, it will go to the correct method, and it will generate the output, and it will, now it will not directly give it to the user. It will pass the output to the next component where we need to print it. So the output will be passed to the print component. Now the print component will take that input and it will print, and the printout will be given to the user. So now I hope it's clear how different components work together. One input was given to the next component or vice versa. It can depend based on the components. Components will talk to each other to make our system works perfectly. So that's why we need integration test. The input of component A is not compatible for the component 2, our system will break. Unit test passed, component testing passed, but we forgot to do integration testing. System in live will fail. Because unit testing was passed, we test each method. We pass different values to each method, subtraction, addition, and then check the output, did the assertions, it worked. Then as a whole, we tested the math component and the print component using different drivers or the stub. So since like the components are not integrated, there should be a method where we can test each component separately. So then in this case, we can use different other tools or technologies. I will talk about these as well. So different components, for each component, we just pass some input and take the output and test. Components separately tested. Then when we forgot to do the integration testing, the whole system testing we forgot. Then in live it failed because the output generated from the component A was not compatible with the component B to pass it as an input. Because let's say component A, the math component returned integer, but for the print output, for the print component, it requires a string input to print. Okay, now when we do the component testing for these individual components, it was passed because we passed a string to the print component and see how it was printed, and we got the output. It was okay. But when the integration testing, at the integration testing level, component A or the math component passed the integer, but it was not compatible for the print component. So now it fails. So that is why integration testing is there. So now I hope it's clear. It's like if we take these small building blocks as the units, we connect multiple units and build a component. Then multiple components we used and integrated to build the whole. So that's how. Now I hope the categorization based on the level. Then we have API testing and UI testing. So API testing is like these components will talk with using API, or front end or back end will talk using API. API stands for application programming interface. API is the one between either UI or the back end or different components where API is used for transferring these requests and response for the communication purpose. We use the APIs. There are different technologies used, and also there are different tools and technologies also for testing as well. I will talk about this later. And then finally we have the UI testing, the most popular one under testing, where we use Selenium or any other technology or different tools to do the testing, where either manually or using a script, it will go to the user interface and perform different user interactions, and then it will generate the output and compare. So that is UI testing. Then I hope now these different types are clear for you: unit, component, integration, API, and the UI testing. Here on the right hand side, now I have a pyramid. So in the pyramid, you can see at the bottom, the base is unit, and more at the topmost we have the UI. And if you check the shape bottom, when we go to the top, it will the area for each category will reduce. Unit testing have the biggest area, and for the UI we have the smallest area. So why is this? So this is known as the test pyramid.
So if we are creating test cases or if we are doing testing, so this is one good approach to follow. So number of test cases or the coverage should be based like this. You should have the highest coverage from the unit testing, then component testing, then integration testing, API testing, and the lowest is for UI testing. But why? Low coverage for UI and highest number should be in the unit testing. There are multiple reasons. One, this is shifting testing left, where we try to achieve or where we try to do more testing early. Last video also we discussed about this. Start testing early. So unit testing, as I mentioned, will be done by most of the time by developers writing the unit test cases, and if they can catch some issues at the unit testing level, it is very easy for them to fix even without having another release for the QE. So they can do the unit testing and then they can identify issues at the unit level and fix. So it is very easy to fix, very easy to debug, very easy to fix as well. It will lower the time and the cost. Then the component, multiple units combined together and the components are created. Less than unit testing, we should have the coverage for the component and then integration and then API. Then why lowest should be for the UI? Because UI tests are very unstable. They are very error prone. Why? There could be some network issues while you running the test case. And also there could be some locator changes, and due to locator changes it will fail. If there are network issues and some loading takes time, then again the test will fail. Likewise, there are so many reasons for UI tests to fail, but it's not for the unit or the component or the integration likewise. So that's why we need to have more unit testing and less number of UI cases. Also, when we compare with API and UI, API are more stable than the UI test cases for the same reasons. Because from the API, we directly call the API with different requests and parameters and the headers and the body, and then we get the response and we evaluate the response. But in the UI, we go to the UI and click, we fill the data and click on the button. Then from the UI, it will send the API, where there are like two scenarios we need to cover. However, like from the UI test, what we do is the user scenario on the UI, and from that it will automatically send the request to the API call. So under API, we remove the UI part and we directly call that API request and check the response. So if you can cover more scenarios through the API, then you can reduce the number of test cases at UI level, because you have thoroughly tested the API using API testing. Now you know API works well. Then from the UI, what you need to test is the UI components and only those things like the styles or the how the UI behaves and those things only. The different messages or things which were shown on the UI level at those things only. So that's why we need to follow test pyramid when you design the test cases. Always remember, from the bottom things on the pyramid, the bottom items are very stable. It will save more time and cost when you try to fix it, and it's early testing. It's early you find the issues. When it goes to the top of the table or top of the pyramid, those are more stable and error prone. Now I hope this categorization also clear for you, where we categorize the items based on the level of testing, and also we talked about the test pyramid as well. So if you have any questions related to these items today discussed, or anything related to the last video as well, now you know how to reach me. Either you can use the comment section below, or you can drop me an email at qvbro.pro@gmail.com. I will try my best to answer all your queries. Now, the next categorization, it's based on the area, or based on the area where the testing is focused. Under that, there are mainly two categories called functional testing and non-functional testing. Functional testing, everyone knows. Functional testing is the feature or the user requirement, the user behavior we check. These are the requirements. The client will say, I need the e-cart, where customer should be able to add different items and pay at the cart and check out likewise. So there are the features. All the requirements are very clear, all are written, and we follow those, and we have created the test cases. Following the steps on the test case, we do the functional testing. But when it comes to non-functional testing, it's a bit different, and it's hard to do as well, because it's very hard to have baselines for the non-functional, because under non-functional testing we have performance testing, security testing, accessibility testing, compatibility testing, and also we can have like other categories like internationalization testing. Likewise, there can be some other types as well. For the functional, the requirement was very clear, so we are testing against the requirement and we check the expected outcome and the actual outcome. But when it comes to performance testing, it's hard. How can we have these values or the expected outcome for this to check against the actual outcome? So that is why non-functional testing requires more effort, more knowledge as well. Don't worry, I will talk about all these things in deep in our future videos. Today I am just giving the definitions and giving the idea about these things only. So later we can talk more about how to perform each, the tools and technologies used for different type of testing of non-functional characteristics. Likewise, all we can discuss in the future. Okay, so again, coming back to the non-functional testing, the first one is performance testing. So why non-functional testing is important? Is it important or not? So you can share your idea in the comment section. In my point of view, non-functional testing is also important as same as functional testing. But why? So let's recall your experience when you try to log into your favorite social media application. Have you ever seen so many lags there? Or the system is down? Some scenarios like that. I'm pretty sure you have experienced these things. That's because the performance, the system cannot handle that much of requests. In that case, either system will go down or the responses will lag. So that's why performance testing is important. Even though the function is there, the customer can't use the function due to unavailability of the non-functionality. So that is again a problem. Why? Though the feature was there, he can't use it. So then there is no point. Feature should be there. That is covered through functional testing. Then how the customer can use this function correctly? Not correctly, I mean correctly using the function correctly will be covered through the functional testing. How the usability side, how easy, or whether can he use it, or whether it is available, that those things will be covered under non-functional. Even though the feature is there, when the customer tries to access it, the system is unavailable. So that is no point. And again, when the customer is trying to access, then let's say the customer is a color blind person, he can't recognize all the colors. So it is very hard for him to see our UI or identify different components on the user interface. So then again, the customer, we will lose another customer likewise. So those are the usability aspect, giving the features to our customers and enabling them to use those. So that is the difference between functional and non-functional types. So those both we need to cover through our testing. So under non-functional testing, as I mentioned, there are different types. First one, let's take the performance testing, the most common or the most popular one. What is performance testing? So most of the time when we do the functional testing, one user will go to the UI, or a script will run, and that script will also run from one thread which will behave same as one user. But when it comes to actual scenario, not only one user will be using our system at a given time, there will be hundreds or thousands of millions of users based on the popularity of our system. For example, like social media applications like Facebook, there will be more than thousands or millions of users who will be using it at a given second. So in that case, the system should be capable of handling all these customer requests. Otherwise, the system will go down, unable to handle the request due to the high load. The CPU and the memory usage is high and the system goes down, or else there will be a long lag to response, and then from the customer side, it will not be very pleasant experience. So that's why we need to do performance testing. Under performance testing also, there are different types of performance testing: load testing, stress testing, spike testing, also we have endurance testing likewise. So under each type of performance testing, we are trying to simulate different scenarios. Most of the time performance testing we need to do using automation techniques, because it's very hard hard, or it's not possible or impossible to cater these number of requests using manual scenarios. So automation testing will mostly used under performance testing. So load testing, we are trying to send a heavy load for a given number of period, and then we check the behavior of our application, whether it's capable to handle these requests, so it is not capable, whether it will go down. Likewise, we check the output of the system. Then stress testing means, so for example, let's say we know the SLAs is for our system is 100 transactions per second. TPS is 100. That means per given second we can handle only 100 transactions. So for load testing, what we do is like we send 100 TPS for like one day for a long period at the accepted SLA. So we check whether our application can perform well with the given load for a long period. But under stress test, what we do is like, if the accepted SLA is 100, we will try to send like 130 TPS, more than the accepted, for a short period, like 1 hour. So we can do this with combined with the load test. Load test will run for 1 day. Within that 1 day, okay, first like we will run it for 10 hours with the 100 TPS. Then suddenly for 30 minutes, we send 130 TPS, and then again we reduce it, and remaining hours we send the 100 TPS. So the stress test, what we try to do is like we try to quickly stress out our system and see how our system will behave under unexpected load, because we can't guarantee, even though our SLA is 100, we can't make sure that it will behave the same way in the production as well, because there, for example, if it is SMS gateway or something, on special days like 31st of December or the Christmas day, the SMS number will go high, because most of the people will use on those special days. Likewise, so in that case we need to have the stress testing as well. Then spike testing, it is, the period is again short, like for 5 minutes we will send around 300 TPS. The accepted SLA was like 100, but now we are sending it for like 300. We know 100% that it will fail. Most of the scenarios will fail. But the purpose of doing a spike test is, if we receive a huge spike suddenly, how the system will behave, whether the system will go down or can it recover quickly. Likewise, at the time when we receive this 300 TPS, the 5 seconds, let's say 5 seconds, at that 5 seconds, the accepted scenario is like 100 TPS should pass, 200 TPS should fail, because it can't handle. But after we stop sending this, and when we come back to the normal TPS, all should pass. The system should recover quickly. Let's say system didn't recover after the spike. For 5 seconds, we send 300 TPS. When we send the 300 TPS, all failed. And even after the spike is ended, now also all fail. Then we have an issue. So the purpose of spike testing is to see how quickly the system will recover or not, those things. Likewise, there are different variations of performance testing as well. Based on your need, you can use these types of performance testing. So the things which will vary between these are the transactions count and the duration. So you can change those things, and you can do different types of performance testing. I hope now it's clear. The next type of non-functional testing is security testing. So I hope you know why security testing is important. There are so many hackers who will try to steal our data. There are so many scenarios in actual world where it happens. So many companies has to face some legal actions as well due to the security vulnerabilities on their applications. So that's why security is very important. So you need to do security testing as well. Under security testing also you can do different types of security testing, or different tools or technologies. So security testing, either you can perform manually or automation using different tools, but manual testing will be a bit hard. Also, you can hire ethical hacker or a white hat hacker, and then he can help you to find the security vulnerabilities and to fix those. However, security testing should be a regular thing. Like at least every 6 months, you need to do a security audit and identify, because we are using different third-party tools, third-party technologies, different libraries in our code as well. Even though our application is not vulnerable, unfortunately, one of these libraries or tools or technologies what we use could be vulnerable. So those are within our, so those are also a component in our system. So unfortunately, if those are vulnerable and one of the hackers able to come through those, again, our data is in risk. So that's why we need to perform random security testing or security audits. Because the tools and everything is changing quickly, the technologies is evolving with the evolvement, and there are different versions. For example, a couple of years back there was a log4j issue. So that's why using third-party libraries also could be a risk sometimes. You need to use it wisely, and you need to every time update these things with the new versions, with the security patches. And also you need to also do security audits and security testing continuously from your side as well. Then next type is accessibility testing. Accessibility testing is the least concerned item under testing, isn't it? Let's take an example. So when you create your application, when you use your color codes and everything, did you pay attention to the accessibility about the color codes you have used? Because there are color blind people. They can't see some types of colors. If you have used those type of colors in your application, then a colorblind user who uses your system will be struggle because they can't identify different components due to this color variation, the use of color. And also have you pay attention to the size, the text size, because a person who can't see properly, a small letter or elder person, then they will be struggle to read the text in your application. And also a blind person who will use a screen read application. So have you ever thought about your application and the support for the screen reader? So a blind person will also use the applications, and they will use a third-party tool called screen readers. So it will read all the text and elements and everything on your screen. Then to listening that, he will perform different actions. So have you ever thought about these things? No, right? But we have differently abled people as well. They also need to use our application for their purposes. So in that case, we need to pay attention to them as well because they are also our clients. We can't ignore anyone. Every person is important to us. So we need to pay more attention to the accessibility testing from next day. I hope it's clear why accessibility testing is important. And accessibility testing, most of the time we can do manual testing, and also now there are different paid tools and technologies where we can use to automate different scenarios. And I will talk about accessibility testing more deep in our future videos. Under accessibility, there are multiple aspects. You need to think about the screen readers, the color codes, the text size. Likewise, there are different aspects we need to pay attention to. So accessibility is very huge area where you need to learn as well. And then you need to learn the accessibility concepts, then you need to learn the accessibility tools, and then you can do the testing. So don't worry, I will walk you through all these things in the future. Next, we have compatibility testing. So what is compatibility testing? Okay, let's take the example. When you test your application as the quality engineer of your product, you use the Windows computer with Google Chrome browser. So you tested on your laptop where you have Windows OS and Google Chrome browser. And you say all the UI components are working perfectly and everything is okay. But we can't make sure, or we can't ask all our customers to use Windows operating system and Google Chrome. They will use different operating system. Someone will use Ubuntu OS. Someone will use Mac operating system. Likewise, similarly, we can't ask them to use a specific browser. They will use different types of browsers as well. So in that case, we need to make sure our application works well across these platforms. We need to do cross-browser testing, cross-platform testing, cross-device testing. We need to test it on multiple devices, multiple operating systems, multiple browsers. So this is known as compatibility testing. Yes, I know it's very hard to test it in all the available devices and all the available operating systems and all the available browsers and all our scenarios. So that's why you need to plan it correctly. There are different tools you can use for compatibility testing. I will walk you through these as well. Then localization testing, because there are different regions in the world. Some will use Arabic, some will use English, likewise some will use Chinese. For each region, based on the time zone or based on the region, based on the IP address they access, from those things we will get the information and we will try to customize the output we show to the user, mainly from the, so we take the IP address, and if the user is from the Arab region, so let's say Dubai, so then we try to show the website in Arabic letters, so the default. Then if the user is from China, we try to show Chinese characters, likewise. So this is localization, internationalization testing. And also based on the time zones, there will be different things on your different features will be blocked, likewise. So those things you need to test. So for that also you can use different tools. You can do manual testing or automation testing, likewise. So these are different types of non-functional testing. So I hope now it's clear the difference between functional and non-functional and why non-functional testing is important. I hope all these things are clear. So this is our third categorization. It was based on the area. Now let's go to the other categorization where we have categorized the testing types based on the objective. Objective of testing is always like to find defects, but this is at different levels. The objective will be different. So under that we have smoke testing, sanity, regression, exploratory, acceptance. Likewise, there are different types. What is smoke testing? Smoke testing is like when a developer creates a new build and give to the quality engineers to start testing. So without running all the test cases or running the whole test cases, the automation or manual, instead you can start running some few test cases, some very important test cases, and see whether the build is stable or whether we can accept this build to testing. So that is a smoke testing. Smoke testing is a good candidate to be automated because every time when a build is there, you need to quickly run it and check the output. So then if the smoke testing is automated and if it is plugged into the CI/CD pipeline, when a developer pushed a new branch or the new tag, then smoke testing will be running automatically and it will give the results. And if it is passed, okay, it will be accepted, and it is failed, it will be rejected. So that is smoke testing. Sanity testing is also a bit similar to smoke testing, but it will have some more test cases for the sanity. So this is like after accepting or before releasing or something. Let's say again you can do the sanity testing. It will have more test cases than the smoke testing. Then the regression testing. Regression testing is when you have a new feature, the new feature will be created on top of the existing features of the system. So let's say you have the e-commerce application and recently you wanted to add SMS facility to your system. So you do functional testing and non-functional testing all, and also the functional testing will be done for the new feature. But after testing the new feature, you can't release this because releasing this will break some existing features. You need to test that as well about the existing features too. Regression also is a good candidate to automate because it's when the system grows, the number of test cases grows, and with the short time, you can't test all the scenarios manually. So if you have automated the regression, then you can quickly go and run the regression suite. So the new features you create, you will test manually, or then you create the test cases, the automation test cases, and then you add these to the regression suite. With the system growth, your regression suite also grows. I hope it's clear. So regression is all about the existing features. We need to make sure that addition of the new feature didn't break the existing features. So that's why we have the regression suite and why regression testing is very important. Then we have exploratory testing as well. Exploratory testing means we are not following some existing test cases. So if you can remember our last video, I discussed about the pesticide paradox. That means if we are using the same test cases again and again, you will not be able to identify new issues. So that is the pesticide paradox. If you have exploratory testing, or if you do exploratory testing, you will not follow any test cases or any steps written, any predefined test cases. Like first you do your manual testing and the automation testing for the new feature. Then you run the regression suite as well. After like couple of cycles, then if you have more time, then you can do exploratory testing and the ad hoc testing as well. All those things will be more or less similar, where we are not following any predefined test cases or steps. you just go to the system and then you try different things, different new things, new flows, where sometimes you will be able to identify new bugs which were not identified early. So this is exploratory testing. Or else you can ask your colleagues from a different project. So then they will also join, and they are new to the system and they will try to do different things because they are not much aware about the flows and everything. They will be similar to a new user of your application and they will try different things, and one of these flows will break your system. So that is another technique where you can find bugs. So that is exploratory testing. Then we have acceptance testing. Acceptance testing also done at different levels. First one is alpha testing. Alpha testing will be done at our site or the software development company's site. So if we build the product, alpha testing will be done on our side. There we will either get people from different projects and give them to do some testing. So then they will do the testing and identify any issues. So if all good, okay, now we can go to the next level. Then we come to the beta testing level. Beta testing will be done at the customer side. So most of the time you will see there will be beta releases for operating systems as well, and also for different products. There will be beta release, a development release kind, where not all the customers get that. If you like, you can get the beta release. They say, so we are giving new features, but there could be some errors. So you have to accept that because still it at the testing level, beta testing. And if you use this product and if you identify new issues, you can report those things. There will be customer support for you for the beta testing level. So that is happen at the customer side. So you can also support as a customer and also as a quality engineer to the product to support at the beta testing level. Also we have UAT testing, which is called as user acceptance test, where a person from the client side will do the testing. So they will have the UAT document where all the test cases are listed. So they will follow those test cases and do the testing. And if all pass, they will sign the UAT document, which means they accepted the release. So those are the different types of acceptance testing we have. Not only this, there are some other types as well. So however, the main purpose of acceptance testing is to hand over the product to the client at different levels. I hope this also clear to you. So these are the categorization based on the objective of the testing. So these are the different things or different terms or different categorizations which I wanted to talk today. So at most of the places you will see all these things together. Manual testing, then the performance testing, like this. So then it's very confusing. But now I hope with this approach, where I try to do some categorization based on different characteristics of each type, and I hope now this makes more sense to you. We had different categorizations based on the level, objective, likewise, and then under that we try to categorize each type of different testing type. These are not all the testing types we have. There are a lot more types if you Google it, but most of the time the other types will be more or less similar to one of these types. So I hope we have done a good coverage for today. I will stop from here for today, and from next video I am planning to talk more interesting topics. So stay in touch, and also as I mentioned, use the comment section, and also you can drop me a mail at qvbro.pro@gmail.com. I am really happy to help you with your queries. See you soon with a new video. Happy testing.